Hi, it's Ms. House. I wanted to make a quick video over a few of these area between curve problems and tell you that I don't expect you at this point in this fast semester to understand the graphing of all of this. So for the homework assignment, I want you to use a graphing calculator to do these. For the test, I will give you the graph. Okay, so you don't have to worry about not having the graph. So let me show you what I'm talking about. So this is question 20 on chapter 7 homework. I'm at a site called Desmos.com, DESMOS.com. It has the most visually appealing graphing calculator, and it's also absolutely free. So I think it's a great place to go. So once I open up the graphing calculator at Desmos.com, I type in all of the information that they gave me, just like I see it. X equals -2. Just hit return. X equals 7, hit return. Y equals 2x to the second plus 8, and y equals 0. So hopefully from this picture you can see it says find the area between the curves. So the thing between is this space that's in here. So I'm going to snip this for a minute so I can take it over in Paintbrush and show you which area they're talking about. Okay, so the portion that's between the green, the red, the purple, and the blue, that's what they're asking us to do. It's between the green and the purple, the y equals, but they're not interested in all of it. They only want it between the red line and the blue line, which are the two x values. So I'm just going to highlight in here what they're asking us to find. They're asking us to find the area under here. Now, there are all kinds of applications for this, and you'll see a few of them in Chapter 7. So even though we're looking at it graphically and some of the applications, you won't even need the graph, but this gives you an idea. So what we're trying to do is calculate the area of this shape. Now, if it was a regular shape, like a rectangle or a triangle or a rhombus or a parallelogram or a trapezoid, that was one I was trying to think of, we have a formula for it. The problem is there is no formula for this shape. So it turns out that you can do this with integration. Now, notice how this graph it's all connected into one piece. So we'll only need one integral to do it. So we're going from -2 to 7, right? So they're saying find it from over here at -2 to over here at 7. And you always take the top function, in this case the green one's on top. So that's going to be 2x to the second plus 8. Minus the bottom function, which in our case is 0. It's the y equals 0 line. Now, clearly, I don't need to put a -0 here. But let's just say that the purple line was not at 0 and it was at 1 instead. You would have to put -1. But because it's at 0, I don't have to put anything. So I'm going to take that part out. So I need just one integral to do this. And I don't think I need these parentheses because they put the brackets in there for me. So I'm just going to take those out. So see, we're saying take the integral from -2 to 7 of 2x squared plus 8. Now, there's a whole explanation of why this works. And basically what's happening is that they're calculating the area of little rectangles underneath this curve, and they're making them skinnier and skinnier. And that allows us to get a really, really good answer for the area of the shape. So now I'll just go ahead and do the integration. The integral from -2 to 7 of 2x squared plus 8 dx. Now you're just reversing your derivative rules. So you're going to add 1 to the power and divide by the power. You're going to add 1 to the power, which is 0, and divide by the power, which is 1. Okay. Now, normally you would need a plus c, but because this is a definite integral, we don't need the plus c. And so now that I have my integral, I'm going to evaluate it. So I'm going to do 2 times 7 to the third over 3 plus 8 times 7. From that, I'm going to subtract 2 times negative 2 to the third over 3 plus 8 times negative 2. So it's a lot of arithmetic, but of course you're going to use your calculator on a lot of this. So in the first set of brackets, 2 parentheses 7 to the third is 686 over 3 plus 56. And I'm just going to leave it like that, and then I'll come back and I'll combine everything at the end. Minus, I'm going to leave this in parentheses so I don't miss that minus sign to what's in here. This is going to give me negative 2 to the third is going to be negative 8 times 2 is negative 16 over 3 minus 16. So what I've got is 686 over 3 plus 56 plus 16 over 3 plus 16, because this negative is going to both of those. Now I need to add all these. I'm going to use the fraction key on my calculator. I could multiply the top of this by 3 and the bottom by 3 and the top of this by 3 and the bottom by 3 and then do all that arithmetic, but I'm just going to rely on my calculator here. So 686 fraction key 3 plus 56 plus 16 fraction key 3 plus 16 is 306. So the area in here is 306 units. And again, the thing to remember is, because this is in one piece, you need just one integral. All right, let's see what this one turns out to be. So I'm going to do the same thing. I'm going to go to my Desmos, and I'm going to type in exactly what I see, -5. Again, I will give you the graph on the test. You do not have to do the graphs, and y is 0. So this one's going to be almost identical to the last one. You're going to have this curve minus 0, so it's just going to be the integral of this thing, right, evaluated between -5 and 1. So I'm not going to go all the way through that one. It's exactly like the previous one. Okay? All right, let's take a look at this one. X is -2. X is 1. Y is 7x. And y is x squared. So that's x to the second minus 8. All right, so here's my graph this time. Let me see if I can copy this, and the area we're talking about is in here. Until you get to 1, and then over here are actually -1. All of this over here. But I'm not going past that blue line, because that blue line is x equals 1, and they told us to stop at x equals 1, right? All right, so it's going to be set up in 2 integrals this time, because it's 2 pieces. Visually, you can actually see that. So if you needed to find this point, I'll make it clear. What you would do is you would set these 2 curves equal to each other and solve it, and that would be that point right there, x is -1. But we know it's going to go from -2 to -1 because we have a visual of it. And you always do the top function, in this case the purple one's on top. We take our top function, x squared minus 8, x to the second minus 8, and we subtract from that the bottom function, which is the line, which is 7x. Now, if that bottom function had more than one term, I would have to remember to subtract them all. But it's important that you remember it's top function minus bottom function. Now here, the top function is the line, so it's going to be 7x, and minus the curve, which is x squared minus 8. So I'm going to put it in parentheses so you can see why I get what I get. I have to subtract the whole thing, so this minus is going to apply to both of these. So it's going to be a minus x squared and a plus 8. So minus x to the second and a plus 8. And that one goes all the way to the end of where they want us to go, which is to 1, but we pick it back up at -1. Okay? Now, when we do our integration, we have to do it in two parts. You have to do this one and evaluate it at both endpoints, and do this one and evaluate it at both endpoints. Okay? Two completely different functions, so you have to do the integration separately. I'll leave the integration for you to do, but it's just like the one before. Use your power rule and your constant, and then evaluate it at the top one first, and then subtract from it the bottom one. All right, let's do one more where we have to draw the picture. So, and again, as a reminder, I am going to give you the graph with the area highlighted. You don't have to worry about trying to figure out how to graph these functions. So x is -2 to 2, y is 2x, and x squared minus 3. So it's not that different. And look, again, it's two little pieces here. Look, in here and in here. So we have to set it up in two pieces, right? And it goes to -1. I'll make sure that point of intersection is clearly marked. So you have to do the purple one minus the green one, and then the green one minus the purple one. The first one will go from -2 to -1, and the next one will go from -1 over to 2.